All right, welcome back. Monday, getting into some coordinate geometry proofs with rectangles. So today we're going to be doing is taking a look at this shape, and we want to show it's a rectangle. So if you remember, we have this lovely sheet here with just some basic ways to do things. So for coordinate geometry proofs, if we want to show things in the parallelogram, we're just going to show one of these four things. Opposite sides parallel, opposite sides congruent, the diagonals bisect each other, one pair of sides is both congruent and parallel. Okay, and then there's your formulas. For a rectangle, the easiest way, okay, there's actually two methods. The first one that's the easiest actually, all right, is to show that all angles are right angles. Okay, so we're just going to use the slope formula. And remember, we're looking for negative reciprocals. Okay, the other method is to show it's a parallelogram first, and then because it's a parallelogram, or after we show it's a parallelogram, we're just going to show that it has one right angle. So we just got to get two sides that touch to have opposite reciprocal slopes. Okay, for rhombus, like we did before, it's you got to have four congruent sides. It's a parallelogram and two sides that touch are congruent, or it's a parallelogram, the diagonals are perpendicular. We're going to talk about squares in a little while here as well tomorrow. And we're going to, for that, we're going to do that it has to be both a rectangle and a rhombus. So we can do a parallelogram, right? And then rectangle rhombus, or we can just do straight rectangle with four right angles. And then we'll talk about that when we get there. So we're going to focus today just on the rectangle here, right? Okay, so we want to either get all the angles to be 90 degrees, or we want to show it's a parallelogram and then has one right angle. But the easiest way to do this, the way that we're going to focus on here, okay, is that we are going to use the slope formula. All right, that's the big thing here. Okay, so let's go back. So we're going to go ahead and graph our shape first. So go ahead and do that for yourself. And so here's KLMN. And so we're going to use the slope formula here, okay? So we're going to do the slope. So we're going to do M to represent slope. And then we're going to put KL next to it because we're doing the slope of line segment KL. Remember, we're going to do four slopes. So we want to keep track of them, okay? Remember the rule or the formula is y2 minus y1 over x2 minus x1. Now I'm using how the points are written here. K is first, L is second, to do x1, y1, x2, y2. So it says y2, we're going to go to the second point, which is L. That's 2 minus y1, which is 4 from K, and x2 from L is 4 minus K, which is 0. Now the big thing is you just want to make sure that these points for L are stacked over each other. So the 2's on top, the 4's on the bottom, and the same thing for K is that they're stacked on top of each other. So technically, if I put the 2 and the 4, like if that was my y2, y1, that's fine, as long as you're consistent with putting what points on top of what here. And then I'm going to subtract. So 2 minus 4 is negative 2, 4 minus 0 is 4, and so we're going to reduce down and get a slope of negative 1/2. And I always want to reduce because the numbers could be different. I could be like negative 4 over 8, but I want to show that it gets the same fraction in the end here, that we're equal to the same thing. All right, so the next slope is going to be LM. Those are the next 2 points. And so once again, I'm not going to write down the formula again, but we're doing y2 minus y1. So I'm going to M. Y2 is negative 4 minus y1, which is now 2 over. And then for M, it's 1. That's the x coordinate. L is 4, so 1 minus 4. So negative 2 minus 4 is negative 6, or say negative 4 minus 2. 1 minus 4 is negative 3. And a negative over a negative becomes a positive, and so this is just positive 2, which is also 2 over 1. And as you can see, we have negative 1/2 and positive 2, so we do have opposite reciprocals. These are change the sign, flip the fraction. These are negative reciprocals, which is what we're looking for, so that's good. Okay, slope, the next one is going to be MN. So we're going to go second, same thing. Y2 is negative 2 minus y1, which is negative 4. So that double negative becomes a positive, and then it's -3 for n minus -4 again. That's our double negative. -2 plus 4 is 2. -3 plus 4 is 1. And we get 2 over 1 again. Okay. Double checking. Caught the problem. Do you see the problem? I see the problem now. That's why I went and looked. Now here's how I'm catching my error. KL is over here and MN is over here. So these two sides should be parallel and I got different slopes. What I did wrong was I did -3 minus -4 when it's supposed to be -3 minus 1. So I know that I did something wrong because I already know what the slopes are supposed to be. So I got to be careful here. Okay. So it's -3 minus 1, which is -4, and there's our -1/2. So you should know what the slopes are going to be. Make sure they come out that way. And then we're going to do the slope of, and now we're going to choose the first and the last point. So KN is the other line. Okay, so we're going to go from n, that's y2, is -2, minus k, which is 4, over n, which is -3, minus k, which is 0. Okay, now remember, we already know that this should be like -6 over -3 and 2 over 1. So -2 minus 4 is -6, -3 minus 0 is -3, and that becomes 2 over 1. All right, so just cleaning up this equal sign here, equals 2 over 1. All right, so now we have enough to say that this thing's a parallelogram, right? We have opposite sides parallel because we have the slopes are equal. And we also have that each of these slopes, right, are opposite reciprocals to one another. So they all are going to form right angles. So we want to go ahead and make a quick statement and then our summary statement, okay? And so we're going to say that two things we can do. We're going to do straight rectangle. We're going to say KL perpendicular to LM, comma, LM is perpendicular to MN, comma, MN is perpendicular to KN, comma, and KN is perpendicular to KL. This is one way to do this, okay? And so what we're going to do is we're going to say right underneath why this is true, and we're going to say slopes are negative reciprocals, all right? And then we're going to write our summary statement at the end. We're going to say that KLMN is a, is that the name of our shape, by the way? Where'd it go? Yeah, it is. All right. Couldn't see it up there. Is a rectangle since it has 4 right angles. Okay. Now, the other way we could have done this is to say that it's a parallelogram because the opposite sides are parallel with the same slope, and it has right angles since the opposite sides are consecutive sides have opposite reciprocal slopes. I like doing it this way to say that this is what's going on for my work, and this is what's going on with the shape. All right. Number 2, same thing. We're going to do rectangle. This time we're going to use the diagonals. Okay. If we're using the diagonals, we have to do two things. We have to say that it is a parallelogram first, and then we have to get it to be a rectangle. Okay, so we got to do two things here. So we're going to go ahead and graph. So go ahead and graph first. All right, so we went ahead and we graphed. So now we have to use the diagonal. So two things we have to do is we have to get parallelogram first, okay? And that's going to have the same midpoints. And then we have to say, so we're going to have to use the midpoint formula to show that they bisect. And then we're going to have to use the distance formula to show that they're congruent, okay? So for number 1, we're going to do that the midpoints are the same. So the diagonals bisect each other. So we're going to do the midpoint. Okay, and we know we're going to look at the diagonals here. So we're going to do AC first. So remember, the midpoint formula is we add them and divide by 2. So it's x2 plus x1 over 2 and then y2 plus y1 over 2. So this turns into, so for AC, we're going to go to x2, which is 10, plus x1, which is 2 over 2, comma, and then 9 for C, plus A, which is 3 over 2. And so here we're going to get the point 12, 12, or sorry, 12 over 2, 12 over 2, until we get 6, 6 as our midpoint. And I am just trying to make these numbers legible. All right. And so this is the midpoint of AC. All right. And so the next one we're going to do is do dB. So midpoint of dB. I'm going to go ahead and just plug the numbers in. So we're going to go to D first. So 1 plus B, which is 11 over 2. And then 6 plus 6 over 2. And so this is equal to 12 over 2, 12 over 2, and this is also equal to 6, 6. All right, so we're going to make a statement here. All right, we're going to say A, C, and D, B bisect each other. I'm going to go ahead and type. Okay. So AC and DB bisect each other. We know that because they have the same midpoint. All right, the next thing we're going to do is we're going to do the distance. So this is the second step. So we're going to do the distance of the diagonal. So that's AC. We're going to use the distance formula, and then we'll use Pythagorean theorem here, okay? So the distance formula, if you remember, is x2 minus x1 squared plus y2 minus y1 squared. And so this is equal to the square root of, so we're going AC, so x2 is 10 minus x1, which is 2 squared, plus y2, which for C is going to be 9 minus 3 squared. Okay, and so this is equal to the square root of 8 squared plus 9 minus 3 is 6 squared. And so this essentially turns into the square root of 100, which turns into 10. Okay, so that's the distance of AC. And so we want DB to be the same distance, okay? So I'm just going to shrink this down a little bit so I can see both here as we go. We'll do 150, see if that makes it any better. I think it does. All right, so the second we're going to do is we're going to do the distance of DB, okay? And so we're going to go ahead and mark. Actually, we don't have to mark. We can just count it straight across. Look at that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't even have to show any work. We can just do D, and then it's DB equals 10. Okay, that's it. And so now we're going to write our second statement and then our summary statement. So we're going to say AC is equal or congruent. Let's use congruent. Proper math terminology here. DB, since the distances are equal. Okay, so now we're going to write our summary statement of fun. We'll do that right under the graph. So we're going to say ABCD is a rectangle since it is a parallelogram, right? We're going to say what property now? Diagonals bisect each other and is as congruent diagonals. All right, and technically, if we left off the diagonals bisect, we just said it's a parallelogram. Actually, no, we want to say that because we didn't say it earlier. We could have said it's a parallelogram here, okay, and then finished it up with that. But we're going to wrap it up in one statement here. All right, guys, that's it for today. See you tomorrow for squares. Take a look at some trapezoids. Thursday, we're doing a little bit extra here. And then Friday is going to be a little wrap-up assignment in Schoology, little quiz, some extra credit as well. So, all right, guys, have a great day, and I'll talk to you guys tomorrow.